DataFriday. My name is Jean-Georges or JG Perrin, and I'm excited to come to you today and talk about performance, and especially, in the context of Apache Spark, of course. And to do that, I am going to have a little bit of a challenge. Well, I'm going to compare my work laptop with the Kubuntu KFocus and see actually which one behaves better. Okay. Okay. So let's get started. So before we get started, in the code and all, I just wanted to mention that this is really about something you can find in the chapter 16 of Spark in Actions, the second edition. Chapter 16 is all about understanding how caching and checkpointing works, and the different type of checkpointing you can do. For the purpose of the video, I'm going to briefly go over that, but the chapter is pretty well detailed about that, and you will find about what kind of scenarios you can optimize, and find some metrics, find where you've got to place your cache, and things like that. Okay, I'm going to skip this part. That's for you to find out. Okay, so let's look at the code. Let's look at the code a little bit. So, when you're caching, you basically, when you're doing things with Spark, so it's really about building directed acyclic graph. First, you have your transformation one, so T1, then T2, okay, then T3, and at some point you've got an action that is being performed on your data. And that's how it works. What you're trying to do is really about optimizing the result. When you've got, let's say you've got the T1, T2, you want a result there, and then you're going to fork, like you've got, let's say, T3 prime and T3 second. You don't want that when Spark is going to perform the action here and here, that you don't want to Spark to do that once and that a second time. Okay, so you want Spark to do this thing once, and then you want Spark to do this thing, then this thing, right? So this is where you're going to place your cache, and it can be either a cache or a checkpoint, or a non-eager checkpoint. Okay, all these details are really, really well covered in chapter 16. But so you've got, based on your scenario, you will have different performance. So let's run the code and see how it behaves. So this is lab 100 of chapter 16. So I'm going to start. See the code is running. It's created a data frame with random values, generating a title, generating a name of an offer, and a rating on Amazon. On Amazon, and that's it. Okay, and it performs a few operations. So you see that without cache, without doing anything, all this will take something like 3.5 seconds. When you're using cache, it's about 2 seconds, 1.9 seconds. And then you say with a checkpoint and a non-eager checkpoint, it's roughly equal to 1.8 seconds. Okay, so from this, in this context, you can say that the fastest one for processing this amount of records is going to be 1,834 milliseconds with a checkpoint. So, and you can see here the number of records, which is 1,000, which is kind of a ridiculously low amount. Okay, and really, what the parameters I'm building in the session is really 70 gig, 50 for the executor, and I don't have this on my obviously on my machine. The driver, well, at the time I'm already starting the driver. The driver doesn't have 50 gig of memory, and of course I'm saying that I'm going to use off heap memory and how much I'm going to use off heap. Okay, so this is really very well detailed in chapter 16. And then I'm going to run 3 times the same operation, one with no checkpoint, one with a cache, one with a checkpoint, and one with a non-eager checkpoint. Okay, and then I'm displaying the result. If we look at the code, let's look at the code. If I go to process data frame, this is not going to do. See, basically here, what is being done is it's really create a data frame. Sorry, this line here, 79 and 80. This is really where we create a data frame, and after that, I'm filtering the data frame, and then I can actually do things like caching, checkpointing, and then doing some group bys. And that's, if you look back at my diagram here, okay, you've got all the creation here. You've got the creation. You've got the filtering. And then this operation here are really the group bys. Okay, so that's a group by, and that's another group by. And if I look well, it's one is a group by year, by language, and this is a group by year. Okay, so that's also when you see the distribution. You see the distribution in the result here over my, it generates 1,000 records, but I'm filtering only the 5-star, and you see that over 6 language here, it's kind of equally the same value, right? More or less, it's all random, and the same thing for the year. So you see that, yeah, it goes from 9 to 20, but it's mostly the same kind of range all around. Okay, so that's really the exercise for performing that, and that's it. Okay, that's it. So now what is interesting is to see the impact of the machine and analyze a bit of the result. So my Mac is it's a MacBook Pro 16-inch 2019. It's based on the last generation. It's an i7, 6 cores, 2.6 gigahertz, 16 gigabyte of memory, and it is it's a 2600 megahertz DDR4 memory, and it has a GPU, but I'm not really using the GPU there. Sorry, that's kind of small. This, okay, come on, scroll up. Okay. So what is interesting with this one, it's an i7 CPU, so it's a little less when I compare, it's a little less slower than in terms of purely frequency, but it's you see that it has more memory. Okay, I've got 64 gig of memory, and I've got two bank of memory. Okay, and the memory is 3.2 thousand gigahertz. So that's, the memory is a bit faster, and you can see also in the disks that the disk is a bit different as well. But we're not really using the disk here. So roughly in price wise, those machines are really comparable. Okay, so if you're of course you can have a crazy nice Mac, and you will have more memory and more disk and etc. etc. But if you've got a standard Mac that they give you at work, well, this is really what happens. Okay, so if I clear the buffer just here, make it clear buffer. Okay, 100,000 records. That's plenty enough for showing, and on both machines. Okay, so let's have the owner of the Mac, second the Kubuntu. So creating a session, creating the initial data frame with all the records, 100,000 records, and So you start seeing that one machine is performing a lot faster, right? Okay, my Mac is a little bit slowed by the fact that I'm actually using the screen recording software at the same time. That impacts the performance, but and in a pretty big way. But you see that they realize the same thing. And what is interesting is that the behavior is really similar in the term of which one is faster, right? The non-eager checkpoint is really the fastest one for both machines. Okay, so that's what is interesting to look at. I've done quite a bit of measurements, and yeah, you could say, well, between 2 seconds for the fastest here, and less than 1 second for the fastest on this side. Well, it doesn't change that much, right? I agree, it doesn't change that much. But what I did is I pushed it for more than 100,000 records. Okay, so let's have a look at that. And if you have chapter 16 of Spark in Action, you will see a chart like that. And actually, this Excel sheet is going to be in your in the repo as well. So just let me correct this thing. It's a 2019 Mac. I got it in 2020, but it's a 2019 Mac. Okay, so you see that the big thing is I can keep growing the thing. I see the value for 100K is a little bit less than what we get because of the screen recording software that is running. And if you see that here, I could not go past 7 million records. So the machine, whatever I would do, whatever trick I would do with my Mac, I would not be able to pass the 7 million records. Okay, so that's a fairly small, I would say, and these figures are in milliseconds. Okay, so 7 million records. When I was comparing to the KFocus, you see that, okay, I could, you see that, for example, purely on the 5 million here, the Mac is slightly faster than the KFocus. But the big difference is, yeah, I tried 15 million, okay? So 15 million is running on the KFocus. I could create 15 million records. I could create 20, 25 million, 30 million, 35 million, and up to 36 million. So really, compared to the Mac, I could create 7 million records. On the Kubuntu KFocus, I went to 36 million. So that's more than 4 times more memory, and it's 4 times more records. Okay, it would be 28 million. But I passed that and the memory because I have more memory. There's no magic there, but it was just able to go a lot further, and with pretty linear performance. So that's it. That concludes it. That shows a clear advantage for the KFocus. So yeah, this little machine here, it bit my Mac by quite a bit. Not only on the speed, in the lower figures of the lower number of records, but also by the number of records it could actually process. So that was an amazing thing. So that was one find, and of course it's similar hardware price. Okay, yeah, you can do different things with the Mac than the KFocus, but not that much. Okay, so I just had a little fun. If you want to have more details on that, I really invite you to read chapter 16 of the book. It's really pretty dense information, so that's why I would really, you can do a lot with videos, but really for that, I highly recommend the book. So thank you very much. You will find all the results, all the way to execute that on your end in the repo, and that you don't need the book for that. It's down there in the comments, and please send your feedback. And that was DataFriday episode 22. And thank you so much for tuning in and listening to that. Bye bye now.